Hello everyone. Today we are going to look at some interesting topic. Okay, solving a parabolic type equation. Okay, this parabolic type equations. If you haven't take a numerical, a partial differential equation, you should stop watching and revise your notes on partial differential equation. Okay, so numerical solution in solving physics and engineering involve of the linear parabolic partial differential equation. So the linear parabolic partial differential equation is denoted by this equation here, and then you have the two space dimension given as a x t partial u over partial x minus c x t u. Okay, this equation hold within some prescribed region R. For the x given, let's say from minus infinity to infinity and t greater or equal than 0. Okay, where the sigma A and C are positive, and they are positive, and C is here must be a non-negative number. Okay, you can solve this in few types region, but this region that we're interested in, which is the infinite region here. However, you can also have the semi-infinite region, or the quarter plane, or the open rectangle. Okay, so to solve this we are particularly going to look at explicit formula. Okay, we're going to look at explicit formula. Now the derivation to this explicit formula I am not going to give, but you can watch my previous videos on solving heat equation. Okay, oh, by the way, yeah, parabolic type equation. Okay, the parabolic type equation consists of heat equation. Okay, so consider this explicit formula um n plus 1 equals to r m minus 1n plus 1 minus 2r mn plus r m plus 1, and where umn is an approximation to the little umn. Okay, so before we do that, we wanna understand some of the grid points. So let me just explain to you about the grid point where you're given big X equals to m times h. Okay, and then big T equals to n times k. So the grid points are X and T. Okay, your grid points are your big X and T, and this m and n are the integer. So if m and n 0, you have the origin. Okay, now what this tells us, okay? So the explicit formula involve only one grid point at an advanced level. My little t equals to n plus 1 k. Okay, so we're gonna look at this equation here. Now I'll go back to this. We call this a 4-point. Okay, so we call this 4-point explicit formula. Okay, the 4-point explicit formula can be written in a computational molecule, such as given as this. Okay, so it's easy to remember this molecule than remembering the formula itself. Okay, so if this is at n plus 1, this is at n. Okay, I'm looking at you can say this is like the x axis, sorry, this is the y-axis, so this is my y-axis here, and my x-axis, okay, my x-axis, we have here m minus 1, m, and m plus 1. Okay, so if this is r, this is 1 minus 2r, and r here. So what this tells you actually in an actual grid, okay, let me just I can sketch it out for you. So this computational molecule is let's say you're looking at your x and y axis here. Okay, so let's say this is my grid point, right? Okay, okay, it's not that good, but it's okay. So let's say your origin is given as here. This is my origin. Okay, this is where my u and m lies here. Okay, so m is for x and n is for y. So what I can say here, I can say that for this is where my x, this is where my t equals to 0, and this is also where my x equals to 0. Okay, so t depends on this formula here. Okay, while your x here, oh yeah, I forgot to tell you what's the how do you determine your h, which is your usually called the step length. Okay, so the step length is given by this r formula here. So I did mention about my r, but I didn't tell you what does this r leads to. Okay, this r in this formula. Okay, maybe I can just write it down. So r what am I going to do? Okay, r equals to k over h squared. Okay, that's my r. Okay, so if let's say if x equals to mh, okay, x equals to mh, and my big T equals to nk, then you will have the small t as n plus 1k, and also you can have r equals to k over h squared. Okay, go back to my here. So usually all these points here, you can get from your initial condition. Okay, initial condition, right? And these are the values you obtain. These are the values you obtain. Let's say up to here. Let's say I'm just stopping up to here from the boundary condition. Okay. Okay, you can usually you can also use initial to get at x equals to 0, but I'm just pointing it out. So now what explicit formula does, okay, so let's say I want to solve this value here. I want to obtain this value here. Okay, so according to this computational molecule, you can see that I have kind of like triangle, right? So to obtain this value here, I need to use this value, this value, this value, and then I can get the value at t equals to whatever size I want to obtain. Similarly, to obtain this value, I need to get this. Need to use this formula to get this value. You can see the pattern now. Okay, so I can obtain all my value at time t, the specific time t, using this explicit formula. Okay, so that's the general idea. So let's solve one problem. Okay, let's look at one problem. So I'm given, okay, solve ut equals to uxx. Okay, so x is given from 0 to 1 for t greater than 0, and then what do I have? I have my initial condition given as ux0 equals to x1 minus x Okay, this is for the interval x from 0 to 1. And then when x 0, this is my boundary condition. I have sine pi t. Okay, so for t greater equals than 0, and then the other boundary condition, 1t equals to cos pi over 2t for t greater than equal than 0. Okay, so what I want to do here, I want to use the explicit formula, use the 4-point explicit formula for h equals to 0.1 and k equals to 0.001. Okay, so let's do this. Okay, this is what we're gonna do. So first of all, we need to find r. Okay, so we know what is r. R equals to k over h squared. So k is 0.001 divided by h is 0.1 squared. So what do you get? I mean, you should get 0.1 here. Okay, so that's my r. So by obtaining r here now, I can use the explicit formula. Okay, so what is my explicit formula? So I have umn plus 1 equals to r 0.1 um minus 1n plus 1 minus 2r. Okay, so it's like 1 minus, if you look at the formula again, it's 1 minus 2r. So if r is 0.1, 1 minus 0.2. Okay, 1 minus 0.2, that should give 0.8. 0.8 umn plus r plus 1n. Okay, so there you go. So we have obtained this. Now to do this better, I would encourage you to sketch the graph. Now the graph didn't tell me stop at what iteration. Okay, all I know is I need to find for k equals to 0.001. Okay, t start from 0. So what I have here, okay, so let's do this properly this time. Okay, I'm going to divide this. Okay, this is my 0. Okay, and h here is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 1.0. Okay, so I have this. 1, 2, 3. Means some of you, maybe you like to calculate immediately without even worrying, but I really encourage you to do this I don't know what you call this. Is it a graph, a number line? Is it a table? Yeah, I mean, okay, so it's okay if you're not getting a straight line. Okay, this is just a sketch. Okay, let's say I have this. Okay, I mean, technically, if given, okay, let's use all the points given from the, based on the question. So this is my t, right? This is my t equals to 0. This is my t, so this is my k increment. Okay, 0.001. So my t here is 0.001. Okay, so it's like nk, t equals to nk, n is 1. Now this is my x here, but do take note, these are given. Remember, the interval is given x 0 to 1. Okay, and these are my h 0.1. Okay, so having all this information, what I need to do now, I need to find all these values here. 1, 2, 3, 4, 5, 6, 7, 8, 9 values here. Okay, so if this is the point at UMN, okay, UMN, which is my 0, 0, U0, 0. Okay, so I can just use another marker. So this is my big U0, 0. Now, how do you write this? Remember, MN. Okay, this is M. N is always 0 here. Okay, this is my N is always 0. So I will have U 1, 0. Okay, and then I will have U 2, 0, U 3, 0, U 4, 0, U 5, 0, and so on. Okay, you know how to write it now. Okay, these are the values that you wanna obtain. Okay, and obviously this point here is my U10, 0. Okay, this is the boundary value at 1. Okay, so and then what you want to find, the value here in all this value. So this one will be 1, but my N is now 1. Okay, N is 0 here, N is 1. So I will have U1, 1, U2, 1, U3, 1. Okay, and then here will be U4, 1. Here will be U5, 1. Okay, get the idea. 6, 1, U7, 1, U8, 1, U9, 1, and U10, 1. Okay, so all these values I need to find out using the 4-point explicit method. Now, in certain book, instead of writing U10, you can also write them as U1, 0. Okay, 1, 0. Okay, so either way they are acceptable. Okay, it's acceptable because if you look at the formula given here, the explicit formula, you have M in the bottom and N in the top. Okay, but some books you can use this notation. Okay, now if you understand what you want to find now, let's put in the value and find all the initial condition first. Okay, so first thing you want to find is U0, 0. Okay, so what is given U0, 0 when at x equals to 0 or at t equals to 0? So I can use either way. I can use my initial condition or I can use my boundary condition. They should end up giving me the same answer. Okay, so when x is 0, what do I have? 0, right? So but when t is 0, what is sine 0? Is 0. Okay, so my the value at U00 is 0. I'm going to give it to 4 decimal places. Okay, and then for U10, okay, so x is 1 but time is 0. My time is 0. So obviously I'm going to look at this value here. Okay, so you have x1 minus, see, now you understand why I have a comma here, right? So I have x1 minus x. So I have x1 minus x. But what is my x value here? 0.1. So I have 0.1, 1 minus 0.1. Okay, 1 minus 0.1 is 0.9. 0.9 times 0.1 is 0.0900. Okay, so you can see the pattern here. Okay, so this is 1, 0 from the initial. The rest is also from the initial. So I have U20, is given as x, 1 minus x. So I have 0.2, 1 minus 0.2. So I'm looking at this value here, okay? My x is 0.2. So 0.8 times by 0.2, 0.16. Okay, and then u30. I don't have to write it, I can just do it. 0.3, 1 minus 0.3. So 0.3, 1 minus 0.3 is 0.7. 7 times 3, 21. So 0.2100. So I'll look at this equation now. Now I'm going to look at 0.4. So 0.4, 1 minus 0.4. And I have 0.6 times 4, 24, 0.2400. And then you have 0.5. I have 0.5, 1 minus 0.5, which is 5 times 5, 25, 0.2500. And here you have 0.6, 1 minus 0.6. Look at here now. So what happened here? The interval is actually kind of symmetric. Okay, so it's look like back from here, it's going to similar with my 0.4. Okay, it's going to similar with 0.4. So yeah, there you go. So 0.4 times 0.6, so you have 0.2400. And then my 70 is similar with my 0.3, which is 0.2100. Sorry, this is 0.7. Now this is what happened when I try to do too fast. Okay, so let's erase this and get it right. So again, if you already know, you don't have to waste your calculation time. Okay, you can ignore the steps and try to just write down your solution. So now it's going to be like 0.1600. And now lastly, 90 will be, what do I get? 0.9, 1 minus 0.9, which is 0.9, 0.09. Okay, we have obtained all these values of x from 0.1 to 9. Now at u10, this is the boundary condition for x equals to 1. Okay, so what is the equation given for x equals to 1? So you have u1 t 0, right? So you have cos pi over 2 t is 0, right? So I have u10, which is my boundary condition. This is my boundary condition at x equals to 1. Okay, so I have cos pi over 2t. My t is 0. Okay, so what is this? Cos 0 is 1. Okay, cos 0 is 1. So my u10 is 1.0000. Okay, so now what we have here. Okay, so let me just recall what are we going to do now next. Okay, so look at here again, the table. So I have obtained the value for all this point here, right? So I obtained this value and I obtained this value. Okay, now I've obtained all the values for t equals to 0. Again, I'll just going to write it down. This is t equals to 0. Okay, all these values here. Now can I find the value of this one for u11? I can use the explicit 3-point that I've obtained. Okay, but before we do that, let's look at what about the value for this one? Okay, can I use that? Yes, it is given. The boundary condition at x equals to 0, and this value here is also given boundary condition at x equals to 1. Okay, so what are this term here that you write, the u term here? This is my u, this 0, 0, 0, 1. Okay, so we need to find u01. So let's lose my blue. So what is u01? This is the boundary condition at x equals to 0 and t equals to 0.001. Okay, so what do you have? What do you have for x equals to 0? So let's look at the condition here. So at x equals to 0 t, so sine pi t. Okay, sine pi t. So we need to write it down for sine pi t. Sine pi and t is 0.001. Okay, so press your calculator. You should get 0.0031. Okay, that's settled. Now the rest will be all the other values that we want to obtain, such as at u11, 21, 31, 41, and so on. Okay, so let's look at this term first. u11. Okay, I need to use this point, and this point. Okay, which I've already obtained. So my formula is, so this is what the explicit formula that I want to use. So 0.1, okay, 0.1. What is minus 1 is this one. Okay, so 0 times 0.1 plus 0.8 times with u10 plus 0.1 at u20. Okay, so let's do that. So I want to find out u11 equals to 0.1 u00 plus 0.8 u10 plus 0.1 u20. Okay, remember the what I was telling about the triangle that we want to get. Right, so you need to pass us these 3 points here to get this point. This is what you call the computational molecule, 4-point computational molecule. So this is for m minus 1, this is m, and this is m plus 1. Okay, and this is my n. No, n plus 1. Okay, because this is my n. This is also my n here. Okay, this is if I sketch it out like that, you have, okay, this is my n, this is n plus 1. So you're looking at one level high for n. So in this case you have this is my u00. Oops, I cannot write that, but I can actually, but I don't want to choose different. u10 and u20, and this on the other hand is my u11. Okay, so the n is n plus 1. This is for n0. 0 plus 1 is 1 here. Okay, so if you get that correct, now all you got to do is put on all the values you have obtained earlier on. Okay, 10, u10. 10, what do I get? I got it 0.09. So 0.09, and then 20 is 0.16. So I have 0.09 plus 0.1, 0.16. Okay, so this is 0.8 times 9 is 72, 0.072 plus 0.016. So I have 0.0880. Okay, so now move on to U 2 1. Okay, so 2 1 will be, okay, 2 1 will be the next. So starting from here to here in another way, okay, here to here. So this will be my m minus 1, m plus 1. Okay, but let's don't do sketch here so that I don't want to confuse you with this diagram. Just look at the main diagram that we have done. Okay, the main diagram that we have done here is up here. I think you guys already understand how to find it. So to find U21, this circle here, we need this one. Okay, we need 1 0, 2 0 and 3 0. 1 0, 2 0 and 3 0. So we have 0 0.1, 1 0 plus 0 0.8, 2 0 plus 0 0.1, 3 0. Okay, so I know 1 0 is 0 0.09. I know 2 0 is 0 0.16. So all I gotta do is look up for the 9 plus 0 0.8, 0 0.16. I'm pretty sure earlier on this one is 21, 0 0.21. Let's check. U30 is 0 0.21. Okay, so put that answer here. So what do I get? Okay, you have 0 0.009 plus, this is, you gotta use a calculator to do this. Okay, so 0 0.1580. Okay, I have done it earlier on, so I can do it quickly. Now 3 1 will be 0 0.1 U20 plus 0 0.8 U30 plus 0 0.1 U40. Okay, so that will be 0 0.1, what is 20, 0 0.16 plus 0 0.8, what is 30, 30 is 0 0.21 plus 0 0.1, or 40 is 0 0.24. You can look it up, but that's what I got earlier on. Okay, so press the calculator, you should get 0 0.2080. Okay, now U41 equals to 0 0.1 U30 plus 0 0.8 U40 plus 0 0.1 U50. Okay, so now all this depends on how correctly you're pressing your number in your calculator. Okay, so if you get it wrong, then the rest of your computational will be wrong. Now what is 0 U50? I think it should be 25, but let me just check. Okay, U50 is 0 0.25. Okay, so 0 0.25. So what do you get? You get 0 0.2380. Now if you think there are some mistakes in my computational by pressing the calculator, please send me a message. But other than that, this is how you solve it. Okay, now back to 0 U51. Okay, U51. I have 0 0.1 U40 plus 0 0.8 U50 plus 0 0.1 U60. Is it? Yeah. Okay. 4, 5, 6, 3, 4, 5, 2, 3, 4, 3, 4, 5, 4, 5, 6. Okay, so we have 4, which is 0 0.1, 0 0.24 plus 0 0.8, 0 0.25 plus 0 0.1, 0 0.24. Okay, now you will get 0 0.2480. Okay, so you need to continually find U61, U71, U81, U91. Okay, but I know that earlier on, you should get, for instance, we know that U60 is similar with U40. Okay, so U61 is similar with 0 point due to the symmetric. So we have 2, 3, 8, 0. Okay, they are the same. Now 71 is similar to U31, which is 0 0.2080. And then 81 will be U21. What is U21? 0 0.1580. 0 0.1580, and 91 is 0 0.0880. U91 is equals or similar with U11. Okay, yeah, there you go. Okay, so we have obtained all these values for time t equals to 1 by using the explicit 4 point. Okay, we have obtained all this value. Now I'm pretty sure you can go further level up. Okay, I'm pretty sure you can just go further level up. You can find the next value using the same approach. Okay, my pen is not working for some reason. Okay, maybe I should go a little bit. There you go. Okay, you can find the value at t equals to 0 0.002. Okay, but I am gonna stop here because the question just asked me to start with h equals to 0 0.1 and k equals to 0 0.001. Okay, so this is the numerical solution or numerical approximation using explicit 4-point method. Okay, so this heat equation, to solve that heat equation, you can also use any different formula. So there is also a 6-point. Okay, a 6-point formula. Let me just write it down. Okay, you can also have a 6-point formula. Oops. Okay, so 6-point explicit formula. Okay, is given by this computational molecule. Okay, it's 6 point, so you must have 6 point. So if this is 1 point here, this 1 point is for n plus 1, one level up, and you must have 5 points here. 1, 2, 3, 4, 5. This is at level n. Okay, so this 6-point formula is given by, obviously this is my UMN. Okay, this is my UMN. This will be my m minus 2, m minus 1, m plus 1, m plus 2. Okay, so the equation is given as this. UMN plus 1 equals to, okay, so you have 2 over 3r, 2 minus 3r for u m plus 1 m plus u m minus 1 n. Okay, and then plus a half 2 minus 5r plus 6r squared UMN, and then minus 1 over 12 r 1 minus 6r u m plus 2 n plus u m minus 2n. Okay, this is my 6-point formula. My 6-point formula. Again, r equals to k over h squared. Okay. Now, the derivation to this formula is given in one of my other videos on heat equation, so you just gotta look it up. So can you solve this? Can you solve the given example just now, okay, by using 6-point explicit formula? Okay, that's your homework. So okay, solve the same question that I've given on that I solved using the 4-point. Maybe I should write it down in case you don't wanna look back. So we have this equation here, the heat equation, where my t greater or equal than 0, and I have u x0 equals to x1 minus x, where my x from 0 to 1, and then u03, the boundary condition at x equals to x is sine pi t, t less than or equal than 0, and then u1t equals to cos pi over 2t, t less than or equal to 0. Now, I didn't mention earlier on, you can actually find the exact solution for this. Okay, you have to recall your partial differential equation on how to solve this heat problem for finite boundary. Okay, I'm pretty sure you need to use the separable variable and then get the Fourier series expansion to get the exact solution. Okay, so what's the value of h? The h equals to 0.1 and k equals to 0.001. Okay, you can see the difference between this 4-point and the 6-point. Okay, so I think that's all for today, for this lesson today. So I would like to end this video. So I hope to include some Scilab. Okay, Scilab to show that how we can get similar answer. Okay, so hand calculation is good if you have a very small interval for time and x, but if you have a very large interval, you need to use some programming tools to solve this. So Scilab will be a good software to evaluate this. Okay, that's all for today. If you have any question, please leave a message at the chat box. Thank you. Bye for now.